Here's the values we used. All right. Hours of study. How does it affect your score? So this was the table that was used to do these calculations, and I'm going to get the formula for you. Right, I sent you all of these video links. So all these video links will give you the wording for all of this that was done yesterday. Over the weekend, I'm going to set it up nicely. So here's the formula for Pearson's. Okay. All you need to do is just take a look at the videos. And right. So this is the formula for Pearson's. That is what Pearson's product moment. That is the formula that gave rise to all of these calculations that give rise to this value 0.984. That's the correlation using this measuring device, using this formula. Okay. Now, the question now E, asking for the gradient and the y-intercept. Remember we said we're going to use all the formulas in that list. We have used the median for interval, mode for interval, mean for raw, mean for grouped, standard variance and standard deviation for raw, variance and standard deviation for grouped. Spearman's, we are going to do, we do Pearson's. Now we are in linear regression for gradient. So this is the formula for gradient, and this is the formula for the y-intercept. So part E is asking us for the gradient and the y-intercept. So this is the formula for gradient. This is the formula for y-intercept. Now, as you can see, this formula is related to that formula. Okay, to the Pearson's formula. That's why the Pearson's now is more predominant in linear regression analysis, and it is linked also with the y-intercept. Okay, so let's go back to the question. Use the results in part C. The reason why it is saying to use the results in part C to find the gradient, because to find the gradient you have to use that formula here. Formula for gradient in linear regression is not y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1, that would be for a graph. If you have a graph, then you can use y2 minus y1 and x2 minus x1. Okay? So the formula for gradient we are going to use, here it is. M is equal to the sum of n times the sum of xy minus the sum of x times the sum of y over n times the sum of x squared minus the sum of x all squared. Okay, so this is the formula that you need to use to find the gradient to answer part of part E. And to find the y-intercept now, here's the formula. The y-intercept is given the letter C, C for constant, is the sum of y minus m for gradient. So we have to find the gradient first before we can find the y-intercept, times the sum of x over n. Okay? So this is how you find the gradient, and this is how you find the y-intercept. Why it says use the result in part C? Because if you look at the formula for, let's put them side by side. If you look at the formula for y-intercept, you will notice some similarities with the formula for gradient. You will notice that the numerator is exactly the same, and part of the denominator, this missing a sum right there. That's the sum of x all squared. And same thing here, that's the sum of y. So it's like right. So if you look at the formula for the product moment for Pearson's, and you look at the formula for the gradient, you will notice that the numerator is exactly the same, and part of the denominator is exactly the same. So you can use these values to calculate the gradient. You can use results from part C to calculate the gradient. So all we need to do is to get what value we got for this and what value we got for that. Okay, what value we got for the numerator? Let's come down here. Right, so here it is. So just to break the ice, let's compare this with that. What value did we get for the numerator when we were calculating product moment? Anybody? What value did we get for this, that numerator there? Okay. You all are hearing me, right? Hello? Hello?
Yes, sir.
Right. Okay. Let's put them side by side. This is the formula we use to calculate R. As you can see, the numerator is exactly the same and part of the denominator. I send the link. Could have taken a little look at it just to, but just taking a look at this, just making the comparison. R is equal to, and you have this, you have that. What numbers do you think is our numerator here? Let's start with the numerator. What number you think here? What number you think is coming here, up there, as the numerator? Based on what we are looking at there, look, R is equal to, all these calculations were done. You will take a look at the video in detail and follow it. But just by comparing, R is equal to, you have this and you have that, and you have this and you have that. When I say numerator, I mean this. Numerator, we mean this is a fraction. You have the numerator and you have the denominator. So what number you think comes in the numerator based on what you are seeing here?
So like the answer or like
Yeah, I want a
the two
number.
numbers.
What number?
15054.
15054. Logically, R is equal to numerator divided by this number times this number, square root. As you can see, all these calculations was done, and this is the numerator. And it is the exact same number that M needs. Okay? So M is related with R. Alright? There's a link between them. They share the same numerator, which we got as 15054 through these calculations. I'm certain when you take your time and look at the video in detail, you will see how it was done, because the way the video is constructed is like now having a class. Okay, you just take a record of the class and you just follow the class. The only disadvantage, you don't have time to say, "Sir, stop a while, I'll go over this," but then you can stop, pause the video, replay it again, okay, with your pen in hand. Don't sit down and watch the video like you're watching a movie. Mathematics, watching video of mathematics is not like watching a movie. You have to participate. You must take your, copy down those values, copy down the table, use these values, copy them down, and as you're going along, follow it. All right, that's how you pick it up. All right, I'm trying to prepare you all for future, for university, because from what I'm also I getting more calls and more calls, because it's not easy doing online studies, and that is what is becoming more popular. So we can see now that our numerator will be 15054. What do you think that denominator going to be here? And look, I'm going to write it there. Up and down. Up is the numerator, 15054. Just a minute, I have to number. 15054. 100%. Okay. What's the denominator? What comes here for our M? We use 15054 already. We have one number, two numbers, three numbers. We use one already. Which one of these numbers you think come in here as our denominator?
13418.
13418. So this is why now in any question I will be structuring a linear regression question will come right after a product moment. I will not give you a new set of values to recalculate all of that. So you will go back to your product moment results and you will transfer those two numbers you need to calculate the gradient. I will not make you recalculate that again. It's pointless. Okay, so bear that in mind. Because the results for the product moment, you can easily use it to calculate your gradient. Okay, we're going to get a value there. Let's do the calculation one time. Anybody can tell me what the value is? $1.12. Please verify if it's 1.12. 1.12.
Yes, sir.